In this lesson, you will learn how to solve one-step equations using multiplication and division. The first step is to multiply or divide the number on the same side as the variable to both sides of the equation. And step 2 is to check your answer. So the directions are, for each of the examples in this lesson, to solve each equation and then to check your answer. So for each of the examples, I will solve the equation on the left side of the screen, and I will show the check on the right side of the screen. For number 1, 3x equals negative 24, the goal is to get x by itself. So therefore, I have to move the 3. Since the 3 is being multiplied by the x, I take the opposite of multiplication, which is division, and I divide both sides by 3. The 3's cancel, and I'm left with x equals negative 24 divided by 3 is negative 8. So to check and see if this answer is correct, we take the value that we just solved for, x equals negative 8, and we write the original equation, 3x equals negative 24, and I substitute negative 8 in for x. So 3x means 3 times x, so I take 3 times negative 8, and 3 times negative 8 is negative 24. Since both sides of the equation match, the answer of x equals negative 8 is correct. For number 2, negative 4y equals negative 32. Once again, we want to get the y by itself. But since there's a negative 4 in front that's being multiplied by y, I want to divide both sides by negative 4, since multiplication and division are opposites, so that the negative 4 cancels, and I'm left with y equals negative 32 divided by negative 4 is positive 8. So I check this answer of y equals 8 by substituting it into the original equation, and negative 4y means negative 4 times y, so I take negative 4 times 8, which is negative 32, and since both sides of the equation equal negative 32, the value of y equals 8 is correct. For number 3, 42 equals negative 1.4b. So this time, this equation is set up to where the variable is on the right side of the equation. It doesn't change the process for solving for b. We still have a number in front of b, the negative 1.4 that's being multiplied, so I still divide both sides by negative 1.4. So 42 divided by negative 1.4, if I divide this out on the side, I have to move the decimal point over once, so therefore I add a 0 to the 42, and I'm now dividing 14 into 420, and if I take 14 times 3, 14 times 3 is equal to 42, so when you divide 42 divided by negative 1.4, the answer is negative 30. The negative 1.4's cancel, and if you'd like, you can reverse this to say that b equals negative 30. And to show the check, I substitute negative 30 in for b. So when I multiply 1.4 times 30, I have one decimal point, so it's 42, and since I multiplied two negatives together, it's equal to positive 42. The two sides match, so the answer of b equals negative 30 is correct. For number 4, negative x equals 75. Whenever you see just a negative x, it really means negative 1x equals 75. And you still want to get x by itself. This negative 1 is being multiplied by x, so therefore I divide both sides by negative 1, and 75 divided by negative 1 is negative 75. So to check this, I take negative 75 and substitute it in for x. So this negative stays, and I multiply that negative times the negative 75. So I take x equals negative 75 and substitute it in for x. This negative in front really means negative 1 times negative 75, which is positive 75. So once again, the two sides match, and x is equal to negative 75. For number 5, negative 64m equals 16. So I want to isolate the m, so I divide by negative 64 since it's being multiplied by negative 64. So that the negative 64's cancel. And on the right side, I have 16 over negative 64. So if I write that out on the side, I can either use long division to write this fraction as a decimal, or I can reduce the fraction to simplest terms. So 16 is a factor of both 16 and negative 64. So if I divide both numbers by 16, negative 64 divided by 16 is negative 4. So that m is equal to negative 1/4. So to check this, I have negative 64m equals 16, and I substitute negative 1/4 in for m, and negative 64 times m means negative 64 times negative 1/4. And if I write this negative 64 over 1, and reduce the 4 and the negative 64, I multiply straight across and I get 16 over 1, or just 16. The two sides match, so m is equal to negative 1 over 4. Now the problems will look a little different. For number 6, we have m over negative 6 equals 12. M over negative 6 means m divided by negative 6. And to solve for m, since we are dividing by negative 6, we want to multiply both sides by negative 6, since multiplication is the opposite of division. So I multiply both sides by negative 6, since it's being divided. And I'm left with m is equal to 12 times negative 6 is negative 72. So I check my answer. By substituting negative 72 in for m, and negative 72 divided by negative 6 is positive 12. The two sides are equal, so m is equal to negative 72. For number 7, x over 7 is equal to negative 8. So to solve for x, we are dividing by 7. The opposite of division is multiplication, so I multiply both sides by a positive 7 so that the 7's on the left side of the equation cancel. So that I am left with x equals negative 56. So I check the answer of negative 56, and negative 56 divided by 7 is negative 8. For number 8, negative 1/3, which is the same as negative 1 over 3, equals x over 15. To solve for x, I want to multiply both sides by 15, since I am dividing by 15, and you always move the number on the same side as the variable. So that when you multiply 15 times negative 1, you're left with negative 15 over 1 times 3 is 3. And if you take negative 15 divided by 3, it's equal to negative 5. So you can write negative 5 equals x, or x equals negative 5. So let's check this answer of x equals negative 5. And negative 1/3 is the same as negative 1 over 3. And the way that we're going to check this answer, Since both sides do not match, we look at the right side of the equation and we see that it's a fraction that's not in reduced form. So if I divide both negative 5 and 15 by 5, I'm left with negative 1 over 3 which is the number that I have on the right side of the equation. So my answer of x equals negative 5 is correct. For number 9, 2x over 3 equals negative 1/4. I'm going to write this instead of 2x over 3 as 2/3 times x so that you can see that it's multiplication. Equals negative 1/4 is the same as negative 1 over 4. The reason why I want to write it as 2/3 times x is again to show that it's multiplication, and we want to divide by the fraction of 2/3. But when you divide by fractions, you multiply by the reciprocal. So I just take the fraction that's next to the x and flip it around to both sides of the equation. So that the 3's and the 2's cancel, and I'm just left with x is equal to negative 1 over 4 times 3 over 2, and I multiply straight across and get negative 3 over 8. So let's check this answer of x equals negative 3 over 8. And again, instead of writing 2x over 3, I will write 2/3 x, or 2/3 times x, and we want to substitute negative 3 over 8 in for x, so that we have 2/3 times negative 3 over 8 and before I multiply, I want to reduce these fractions. One times negative 1 is negative 1. 1 times 4 is 4. So both sides are equal to negative 1 over 4. So the value of x equals negative 3 over 8 is correct.